It's that time of the week. It's 21 past 9. Here we go.
It's time now for the latest news on what's hot and what's not in the world of technology with Matthew Dickerson on Tech Talk. Here on DCFM 88.9.
Morning, Matthew. How are you?
Look, I'm a bit scared actually, Richard, after hearing how you're going to take on the world today. I'm kind of sitting back in my seat waiting to see what you're going to present
Look
me
out. we're socially distanced at the moment, about 1.5 metres. Look, great story. Newcastle University converting coal-fired power stations to run on fossil fuel free. Now, we had the Prime Minister yesterday talking about gas for Liddell, if Liddell doesn't do coal anymore, Newcastle nearby. What's the story?
Well, there's a huge amount of irony in this story, Richard. Back in 1797, which you'd well remember, John Shortland stumbled across the Coal River, which then was eventually named the Hunter River, and commented on all the coal around the area. So the first export from this colony was coal way back in the late 1700s. And the first railway line was 1831 that took coal from the Newcastle area to the port. And still today, the #1 coal exporting port in the world is Newcastle. And Newcastle University are trying to put an end to all of that. They've come up with this wonderful material that can actually store heat inside the material. And of course, a coal-fired power station is not inherently bad. It's basically just heating up water, turning into steam, spinning a turbine. The problem, of course, is how you heat the water, which is at the moment with coal. So this particular material, the idea is that you can use renewable energy, so you can use wind, you can use sun when you've got that power available, and put heat into these blocks of this material, and then you can use that same material, it's reusable, use that same material to release the heat, and then effectively heat water and spin turbines. So you've got all these power stations across the world, about 6,000 power stations that are run with coal at the moment. So imagine taking all the coal out of those and replacing it with a material that you can capture that heat and then still run the coal-fired power station in the same old way, but in clean energy.
I think it's wonderful. Someone hasn't told the Prime Minister about that, though.
Obviously not, no, he's still focused on gas and coal.
Okay, how expensive is it to make this block to keep the heat?
Yeah, and so Newcastle University's developed the whole concept.
Yep.
The unfortunate part in this whole story is they've now gotten to the point where they're going to commercialise it, and they've partnered up with a Swiss company. No one in Australia wanted to back them on it. So a Swiss company has started. They're doing their first trials over in Europe on coal-fired power stations that they're shutting down in Europe. So that's a bit of a disappointment, but it's still Newcastle and Australian ingenuity doing it. And the cost of it, I mean, people often talk about batteries. The cost of these blocks for the same amount of power is about 1/10 the cost of, say, a lithium-ion battery. So batteries have got their issues, but the problem with batteries, of course, is that you've got this whole other set of infrastructure. What I love about this concept is we've got coal-fired power stations there. Many of them can keep working for decades to come, except we don't want to burn coal. So replacing that coal with this material, to me, just sounds like a brilliant way to convert those old coal-fired power stations. And I think there's somewhere around 2,000 gigawatts across the world that's produced by coal-fired power stations. So a huge opportunity for Newcastle University. And that's where I love this irony, where it started off as a whole coal, the whole reason the settlement's there is because of coal. We might see a whole transformation of that area because of Newcastle University's ingenuity. So love it.
I love the thing too. I mean, it's going to replace batteries. The only other question I've got to ask is to make this block, how much energy is going to be used to make the block?
Well, the making of the block is actually common materials they use, and obviously there's a patent and a fair bit of secretive information about how it is made exactly, but there's not a lot of energy used to make it. The main amount of energy is when you're putting energy into it, and the conversion of that energy back into heat is actually very efficient. So you're getting that energy put into it by, again, renewable energy. You've got wind turbines, or you've got solar farms, and it doesn't matter if they're not spinning at the moment or if the sun's not shining at the moment. That energy can be put in when that excess power is available. Then those blocks can be used to then basically convert that energy back into heat and heat up your water. So it sounds like a brilliant solution. Commercial trials will be underway shortly, and we'll see what happens from that.
I'm going to keep an eye on that story. That is really, really a good story. Okay, now what did Microsoft find at the bottom of the ocean? I can't believe this. Well, they dropped a container into the water, didn't they?
They did. You don't often associate Microsoft with digging around the bottom of the ocean to see what they can find, but they've pulled up their own data centre. About 2 years ago, about May 2018, they dropped a data centre to the bottom of the ocean, and a couple of reasons for that. The first reason was one of the big costs in running a data centre is cooling the data centre. When you put all these servers together in a tight space, it obviously generates a lot of heat, so you've got to cool it. dropping to the bottom of the ocean, where it was very cool anyway, took away a large component of those heating costs. And the second reason they wanted to do it is because humans want to go and touch their servers. They want to fiddle and play with their servers, and that creates other problems. So by putting it at the bottom of the ocean, that took away the ability for any human to go and play with it, touch it. There was no little door you just slip into and go and play with your servers.
Oh, I've worked at another radio station where we had lots of servers. I used to love going and playing with them.
Exactly, you're the problem. And the last thing they did was they took out most of the oxygen out of the actual container and filled it with nitrogen. And so there's less corrosion if you've got nitrogen there. They ran that trial for a bit over 2 years, and then they pulled it up to have a look at it all and also analysed the results of how it all operated. So, for example, failure rate, they had 855 servers, only 8 servers failed, which is a much lower failure rate than you would normally expect to see in a data centre of that similar size over a similar time frame. So that was good. The performance was all great. So the cost of it all was the heating costs were good, but then the cost of building the vessel that was completely waterproof, dropping to the bottom of the ocean, there was some additional costs there. But I can see as we get tighter and tighter for space on land to build more data centres, and as the heating costs keep going up, then this can be a viable solution. It was really just a test by Microsoft, but I can see that this will be a viable solution going forward.
Well, you've got a lot of hot containers down there somewhere in the water. They'll attract tropical fish.
They did find a lot of barnacles over the outside of the container, actually.
Anyway. All right, very quickly on this one, there's a smart helmet to warn drivers of police, road hazards and traffic, and they're completely sold out. And you really can't have things that warn about police and radar anymore, can you? So this smart helmet may cause some problems.
It may cause some problems. I'm a bit concerned about what the law enforcement might actually think about this, but essentially it's a helmet it's a bit like an F1 fighter pilot that's got so much information in there. So it's actually got indicators inside. So if you're using satellite navigation, for example, it'll tell you when to turn left, when to turn right. There's headphones inside it as well, so it can give you audio clues as well. It's got flashing lights inside there to tell you if there is a speed trap coming up, for example, which, I'm not sure of the legality of that.
Well, my car tells me when speed traps are coming up.
And?
And?
Legally?
Well, I don't know. It was just in the car when I bought it.
Okay, well, the jury's out on that one. We'll get some legal advice around that one. It's also got the ability for a dash cam in the chin of the helmet, so you can record things as you're going along. It's basically a helmet that's got every bit of technology you could possibly think of, all built into the helmet. And I wanted to buy one. I thought it sounded great. But you're right, they're sold out. $1,599 for the first model. That was a carbon fibre model, but sold out the first production run basically before the production run had finished. So something that I can see more and more technology built into the good old-fashioned helmet. I also assume that if you have an accident, it protects your head.
Yeah. Well,
I'm not sure about that part.
Yeah, I could say something else, but I won't. We've got to move on. It's nearly 9:30. Matthew Dickinson with Tech Talk this morning here on DCFM 88.9. This is a troubling one. And when you sent this to me, I couldn't believe it. Is your physical key for your house safe from hacking? And the answer is
no, it's not. And so most people, like I've got lots of technology around my house. I've got fingerprint and to get into my house, and I've got access from my phone to open doors, and people say, oh, you're worried about being hacked. And not really. I put lots of safeguards in place to try and stop that. You think the good old-fashioned physical key that you just stick in a lock and turn and the tumblers turn inside that, you think, well, that's pretty safe. But researchers at the University of Singapore, now I'm not sure why they're researching this, because it sounds like a crime school they've gone to, because they've worked out a way that they can listen to the key being inserted into a lock, and by the different noises that key makes, they can work out then the height of each little part of the key, and then they can feed that into a 3D printer and print a 3D version of your key. Sounds unbelievable, but this is what they're doing now. They can do that by being next to someone with a smartphone. So if you are unlocking the key, the door to your the front of your house, and I was standing beside you, I could just turn my microphone on my phone and listen to it, and that would give me enough information to replicate a key. Or if I want to break into someone's house later on, just leave a microphone near the front door, fairly well hidden. You can get some pretty small microphones.
Yeah, in a pot
and then
plant.
come in a pot plant, for example, then come back and retrieve it later. And that sound of that could actually get to the point where you could say, I can now 3D print a key. Now, the researchers are basically saying, here's what people could do. Here are some ways to prevent that. And then they've got some strategies to try and prevent it. One way is to put your key in your front door slowly, which is quite interesting, because as you put it in at normal speed, that's when it can pick up those noises. If you do it very slowly, then it doesn't actually generate the same amount of noise, so you can't really pick up that noise.
Oh, well, I'd be safe. because I've got trouble putting the key in the lock anyway, and I'm always very slow because
Is that an age thing, is it?
it's worn out, and so I'd be right.
So you'd be right. But it's interesting just the extent that we go to, where technology is at now, just by listening to that, they can start to pick up things that are occurring in there. And again, look, I'm a fan of electronics on your house, so maybe a bit like we have two-factor authentication to get into various things on the internet, for example, or apps that we use, two-factor authentication might be good on a house. In other words, have a key to get in your house and some form of electronic locking, so it makes it a bit harder. And really what you're trying to do with any lock that you've got is make your house a bit harder than the house next door. So they look at your house and they go, oh, it's too hard to get in. Look what they've got there. I'll go next door. And not good for your neighbours, obviously, but you're just trying to make it a bit harder for them.
Indeed. Matthew, always good to talk to you, and some very interesting stories this morning. But the one that we're going to keep an eye on is the story we did first of all this morning. That's Newcastle University and the heat block, for want of a better word.
Fascinating.
Fascinating indeed. Talk to you next Wednesday.
Thanks, Richard.
DCFM 88.9, and it's now 28 to 10, and we have news at 10, and outside at the moment it's a bit blowy, so let's see what the wind is doing at the present time. It's up to about 35 kilometres an hour, 40 kilometres an hour at the airport, and we're on 20 degrees at the moment.